Welcome to part two of our four-part Queensland Government Meraki Network Readiness session, as sponsored by Data3, Cisco and Meraki. My name is Simon McCrosty. I'm the Meraki Partner Lead at Data3. The topic for today's session is Next-Gen Wireless and Controllerless Architecture, and will be presented by Scott Williamson from Cisco Meraki. There'll be an opportunity at the end of the session to ask questions, and I'll now hand over to Scott.
G'day, thanks for that, Simon. So as Simon said, we'll be covering wireless this week. So last week we covered switching and probably an intro to Meraki and switching. Like I said, I wasn't going to cover the intro every week because it'd get a bit boring if you had to watch it every week. So today covering wireless, what we've added new around the wireless, a little bit about how we manage to do a lot of the fancy stuff without a controller or on-prem devices apart from the access points themselves. A lot around Meraki health and visibility, and all the other little bits and pieces that can be enabled inside. I'm not going to go deep into everything, because it could spend a lot of time on our guest services capability, all those sorts of things, but I will point towards a design guide that can help on that. So we get going. The Q&A panels there, ask questions, or you put your hand up and we can ask at the end if I've got time. So I will cover the Meraki mission statement. So this is what everything that Meraki we believe in, and run through this mission statement. And that's about simplifying powerful technology to free passionate people to focus on their mission, which is all about the work that's done in the back end of our cloud to make technology simple, and in the front end to make it simple in the dashboard, to free up people like yourselves, the passionate people who care about business outcomes and what your companies are trying to achieve, which is what your mission is what is the company there for. A local council isn't there to have the best IT shop in the world. It's great to have a good IT shop, but to provide the best value to ratepayers is their focus, and the same with transport and the same with education. Inside there. And then so what we try and do is make running our environment so much easier to focus on that mission inside there. Technology that simply works is really about our back end and the rich capability of the cloud, with all the smarts in the back end of that, that makes our hardware the best hardware, with our software running on that desktop, the best software running on that hardware, to have the best quality hardware and software in the field inside there. We talked about this last time. I won't go into it, but all the benefits of cloud solutions, which is simple zero-touch deployments, that all the data doesn't flow into their cloud. It's all stays on-prem. If the cloud does go away, that everything keeps running, which is quite important for wireless. To be pretty bad if our if you lost internet connectivity more so than our cloud going down, that all of a sudden wireless would stop. That would not be a great thing at all. Things that would be affected is if you're using splash pages on a third-party site or whatever, then they would obviously be able to be served. But all the core functionalities of corporate Wi-Fi would continue to run in there. So I won't go into too much details on that. Now, so how does wireless work without a rack full of servers inside there? So the power of Meraki is really our dashboard inside there. So, an IT admin configures their intent on the dashboard. That configuration, is obviously pushed to devices inside there to do that functionality on premise in there. Any changes that are recorded, are pushed down the device and stored in the cloud. And then we have a back end of our cloud that does a lot of the heavy lifting around, radio resource management, and those sort of capabilities where we'll offload that compute to our back end of our cloud and then update the devices in the field based on that. Is really what the magic of that is, a thing called M-Tunnel, or the Meraki tunnel, or the Magic Tunnel inside there, which is a fully encrypted tunnel from each device to the cloud, which provides that secure communications and that path for that connectivity to happen inside there. An example of that is auto transmit power on access points. This is just one example I'm going to talk through, where every access point, samples the signal noise ratio for all the devices around them and themselves to understand what's going on. They feed that data up to the cloud, and then every 20 minutes or so, there's a decision, or 20 minutes, there's a decision that's made from the cloud, where we'll then push that down to devices to adjust their power or their channel inside there for doing auto channel, to keep that going. And that's enough for wireless. And then we'll do it 1 dB iteration, so we don't go and put an AP on full power and then 1 minute put it on low power. Wouldn't be good for clients. So we just slowly trickle that around and keep that inside there. Typically, on a good design RF environment, you wouldn't see too many changes. But that's how it's all done in the cloud, rather than, an on-premise controller doing that or trying to do that inside the APs. There are other functions like layer 3 roaming that I'll talk through in a minute, where we do all that all on-premise. There's no need to do it in the cloud because that would add too much delay. If we had to wait, for something to make a decision for a layer 3 roam to work, wouldn't make sense to do that in the back of the cloud, to reserve that for locally. So what are we doing to make wireless more intuitive, to make it easier for people to run? So there's a bunch of capabilities that are just included in dashboard. Some of those are historical RF analytics, and we'll have a look at a thing called Meraki Health further down the track, which tells us everything that's going on there, the signal strength, the clients. If we're going into triaging a problem, we can go and use that information. Now, up until a little over a year ago, we just provided these graphs, and it was up to people to interpret that information. I'll show you what we're doing and how we're changing that down the track in there. The location information, so every access point, listens to the client devices around it and knows what's going on. We can use that to count objects that are Wi-Fi inside there. MAC randomization, go and Google that, adds a bit of complexity in there where we would fit that, that use case with cameras or something nowadays. But, for devices that are connected to the network, I can count all those devices. I can geolocate where they are, and in the dashboard we provide that information. So location heat maps here gives us a view of how many devices are connected, seen, or in the area for a period of time, and we can count those, and when they come back and forwards, how often they come into the environment. So that's just provided in dashboard nice and simply. And then in our summary reports, up to date, we've had this anomaly detection where we'll say, hey, there's, something weird going on here where we're seeing more usage on this day than other days. It's out of sync from what we've seen before. Or here's the clients that have the highest usage, so I can go off and work out what's going on there, in that sort of, simple management. That's all provided in dashboard. Obviously, which I'm not talking about in this session or any of my sessions, which I probably should do, is all this, majority of this data is exposed by the API as well, where it can be pushed off into other systems, or people can write their own, capabilities around that, or, APIs, new CLI is what you'll hear used as well. We can start to, provide that information, as well. Now, I'm not going to run through all this in detail because, basically I've condensed, like a 4 to probably an 8-hour training session into, 45 minutes to an hour of content in there. But we have a really good documentation, and our documentation site's just been refreshed as well, with a better layout and format and all those things. But we've got a really good design guide. You won't be able to find this best practices guide directly in there, but if you search best practices guide, you'll find like the high density wireless best practice guide and those guides in there, which all build into a master document inside the Meraki documentation system, which is this Cisco Meraki best practices design, which covers every single product. It's a massive document, and it's my go-to. If you ask me easy questions, you're probably likely to get a link off to the section of that document so that you can read the context around that rather than me re-explain it. This document goes through a whole heap of configurations, things to think about if you don't just want to turn them on and then work it all out later. Inside there, like how to set RF profiles, what's minimum bit rates, bridge mode options we have on the access points. When we're configuring access points with extra ports like the MR30H, this little fella here that has LAN ports on it, wall plate AP, how port profiles can be figured on that. SSID availability, so we can tag SSIDs in the dashboard and have them available at certain hours or only available on certain access points, like the foyer access point has the guest, SSID, not the meeting rooms or something inside there. The firewall and traffic shaping capability on the access points, we can do per client traffic shaping or application level traffic shaping on them, or blocking at layer 3 or layer 7. I'll talk a little bit about the enhancements we're doing for that as well. Group policy and how that applies to the full Meraki network and the wireless, which gives us the ability to set things like firewall and traffic shaping, but then use group policy to pivot that config per user per group based on, how a person's connected to the network or device type, or how they've authenticated with a, radius attribute handed out for that, where we'd use in a traditional Cisco world something like aerospace ACL attribute to push down a downloadable ACL. In a Meraki where we would use group policies for that and still use aerospace ACL attribute, radius attribute to set that. Sentry policies, which is our ability to use Meraki Systems Manager to, basically do a light version of 802.1x authentication without having to have AD servers light, where I can say, hey, I trust this device because it's got Systems Manager on it, it's running the latest patches, it's got this capability of automatically configured the wireless network on there so the user never has to know anything about the SSID and that capability. And I'm going to allow the network, because it matches a security trust or it's in a geo zone or whatever, to make it really simple for managing devices. And that can be extended to contractors' devices and the likes as well. There's a bit in there covered about mesh. All Meraki access points mesh. It's probably the heritage of pre-Meraki with a project from MIT called RoofNet. That same algorithm still sits in there today. It's been enhanced a couple of times, but they'll auto mesh. Like even if you start up a Meraki access point, never connected to your network, claimed in your dashboard, after a period of time, it'll auto mesh into that network without any, LAN connectivity. Obviously, you need to give it power. We haven't quite worked out the power over wireless yet. To be able to mesh in and have that functionality. It's also good when you have LAN failures, like switch uplink failures and that kind of stuff, where the access points will auto mesh to other access points to help limp home in those capabilities. Obviously, packet capturing on all Meraki devices are there. We can do client filters and do packet captures on an access point thousands of kilometres away. Air Marshal, which is all around RF protections for people trying to mimic my network or control the network from a radio point of view, and location services, which is being enhanced as well. So like I said, I'm not going to cover too much details on all those. I'll cover a few of these as we run through some of the stuff that I see people either not configure it needs to be configured, or configure it but don't really understand what it's doing. So there's a lot of enhancements in all, the Cisco portfolio of access points around, integration with what Apple want us to do and standards-based capabilities inside there to give the best experience. Some of these over the right-hand side here is a thing called Fastlane, which is about getting quals over the wireless network where we configure an end device. Again, in this case, an Apple device. We might use something like Systems Manager on there to say, hey, this application, obviously Cisco WebEx gets, the highest quas capabilities on the network, whereas YouTube gets the lowest. And we can mark that on the client device, which means it's on over the air before it gets the access point, and then the access point controls how that's then received on its receiving radios and transmitted in there. So that's Fastlane and wireless markings for quas. And then around enhanced roaming capabilities inside. So what I will caveat with things like 802.11k, V and R is that these are all most of them are all device dependent. So if we've got older legacy devices, they don't always interact well with some of these, where we'd have to disable them. But if we've got newer client devices, it makes it a much better experience. Things like 802.11k, the client receives a list of available APs to roam for, as opposed to, hey, I want to roam to an access point because I've lost wireless coverage, and then reaches out and beacons and try and find someone. So what K does is the client can receive a list of APs to roam to, and it helps us influence the client, the wireless network influence the client on where to go inside there. 802.11v extends that, basically giving them the best AP to roam to in there. Again, allows us to influence where they go. And then 802.11r is about sharing the keys, the authentication keys across access points, so that when client does do a roam, or particularly a layer 3 roam or a voice roam between those, it is as seamless as possible, where it's all pre-shared so that you don't have to, the keying is pre-shared, not things, so that the client can roam really simply without having to re-authenticate every time. If you're doing a voice call, and if you had to re-authenticate, that, 100, 200 milliseconds, would cause a delay in the voice or drop that voice call. Whereas things like 11R are kind of needed in those environments. So just got to keep in mind device support and those capabilities in there. This is just showing here that, our normal page, it shows us what capability a device has. So here 11R is off, but the device is capable. So we at least know when we're triaging a problem, we can go and see what support it is. Now, historical RF analytics is in the dashboard. On an access point, it's the last tab. In there, that gives us a detailed view of what's going on. And you see these little blue dots along the top here. That's telling us when there's events, auto channel changes, interferers, power changes and that kind of stuff. So it helps us triage a problem, gives us a nice view. There's also a real-time view too, where we can go and look at that. And on the access points, there's also a spectrum analysis capability as well. It allows us to go and look at the radio to actually see, that's going on. But these are when you're getting into deeper any sort of wireless issue, that those tools are there to help manage that. And, at your desk here with access points, thousands of kilometers away. A little while ago, a couple of years ago, we introduced a capability called RF profiles. So previous to that, with a Meraki network, you would have to configure the SSID or the network for the RF performance, and then everything was stuck to that. That wasn't very flexibility. It wasn't very flexible. But so what RF profiles does is allow us to have 100 access points in a network, for example, in a multi-story building. Then one area might be the foyer area where we want to have higher power, less access points, less client density. So we would have a foyer area RF profile and tune that network, that profile accordingly, and add those access points into that. Then we might have an auditorium area or a training room area where we want to have a lot higher denser access points, wind the power down, more clients per access points, more clients overall, in those areas where we'd have an auditorium profile, or you would tune it yourself based on what you wanted to in there. And same with outdoors. I might have like a outdoor area and I want to just turn the power up and get it to go further, regardless of client support to be able to transmit back to it. But, I want to be able to hear that. But then you'd have a different profile in there. And that can all be managed with a thing called RF profiles in dashboard. It also gives us the ability to, tune a whole heap of stuff like 2.4 and 5 gig, the channel width assignments, auto channel settings. Manual channel settings. You don't want to do auto channels, removing channels from being used if we don't want to use those. A capability called RX SOP, which is the ability for a client, for an access point to ignore clients below a certain signal strength so that they cause them basically to roam. Really useful in high density wireless and maybe even outdoor capabilities, but also very dangerous too in there. So that's RF profiles and we can do in there. Now around security, I see this a lot in education, where everyone wants to, do ARP attacks on networks and then, claim that they're the router for the network to get connectivity out, so they channel all traffic via that client and out. There's a capability on the access points called client isolation, which allows us to, toggle that on. Basically, there's a lot more words here than what is in dashboard. In dashboard, it's either an on or an off, which would then block, east-west traffic between clients in there. And also, the capability, is also around, I got an IP address from DHCP. So therefore, I can only have that IP address. I can't just go and pick up any I want to be or anything like that. So even if I was trying to do some sort of ARP poisoning attack and everything, and I successfully changed my IP address to a different IP address, as such as the gateway or the router, that wouldn't be honoured in the network. The wireless network would just ignore that client over there. So very useful, especially in education spaces and public Wi-Fi spaces where you might have an open SSID and you're trying to, stop bad stuff from happening. Now, one of the magic of Meraki is a layer 3 roaming without a controller. So a lot of the cloud-managed wireless companies require some sort of on-premise box to do this, some controller or an edge device or something to assist in layer 3 roaming across there. So Meraki's really focused on this for a number of years and has a layer 3 roaming capability where we synchronize, state table across access points inside a group. We can synchronize to tens of thousands of clients to be able to automatically roam across there. Now, layer 3 roaming, you have to make sure that your design of your building is suited for that. And, typically if it's a very large building, we would then have separate layer 3 per floor or per groups of floors for our wireless networks. If we don't have to, it's easier not to. But, that functionality's there. In R26, it says there we have fast roaming support. That's when our latest code is R27. I probably should have taken that out in there, but it supports all the different authentication mechanisms, supports that layer 3 roaming, where we can have that ease of roaming from clients, maintaining the same IP address, not having to re-get that and then, disconnect from the network and reconnect in there. So, super powerful function. I was going to cover that in more detail, but that's enough for now. So for firmware releases, we're currently on a thing called MR27, which is our stable release currently on all the access points, all the current generation access points inside there, Wi-Fi 5 and Wi-Fi 6, 802.11ac Wave 2 and 802.11ax, or Wi-Fi 6 and 5 as we should be calling it now. So what have we added to that? There's a bunch of functionality or capability been added to that, which, this is the stuff that we just add to dashboard. There's no, enhanced license or extra capability. It is just, as long as the AP has that functionality and it's in the firmware, that feature is there. One of those is a thing called Identity PSK. So what Identity PSK is I have a single SSID for a network. Now think IoT devices, because this is where it makes sense, where I have a bunch of sensors that's connecting to that network, but I don't really trust these sensors, and they're all from different manufacturers, and they all want to talk to different back-end clouds. They don't support 802.1x authentication or anything username password. It's just they just want to have a pre-shared key, for example, in there, and they can configure an SSID. I might have some basic authentication. So Identity PSK is around addressing that use case, where I can have a single SSID called IoT devices out there, or just a single SSID, and then I can go and configure an SSID per group of devices, where I can say, hey, IoT group 1 connect to this, and this is their pre-shared key. IoT group 2 connect to that, and this is their pre-shared key, and 3, things. So door sensors from one manufacturer, temperature sensors from another manufacturer, and maybe even, security cameras from a non-Meraki manufacturer that don't provide, rich security functionality. And then based on that, I end up grouping devices with their own pre-shared key, and I can have a firewall or a group policy, I was talked about earlier, bound to that, which will then give us, layer 3 firewalling capabilities, traffic shaping capabilities. So I might say, hey, these door sensors can only talk to the door server in this IP range, and they can only do a maximum of 1 megabit per second or 100 kilobits per second. I can go and police that and do that per there. That means I'm not going to do an SSID per group. I'm just going to have one SSID for them all to connect to in there. Now that can be done with Radius, ICE or any Radius server that supports that functionality, like free Radius, for example, or natively in the dashboard without any Radius server in there. So I can just go and, at a site, I've got these 20 sensors that want to connect in. I can just go and create them their own pre-shared key each and configure them and put them on that network. So really, really powerful in there. WPA3 was added in that support as well. So here, let's just say MR27 gets WPA3 support across them. So that's a software upgrade to get that support. You can go and turn it on now. It'll fall back to WPA2 depending on which mode you want to have on there. So that's been added to the access points too, which is cool. In our what we call our Wi-Fi 6 access points, which I'll talk about at the end, the ranges, and so we also added the Cisco NBAR engine to the back of that. So NBAR is network-based application recognition. So it's really, really good, cool fingerprinting for applications so that we can, do better quality control, understand what applications are in there. Now we had to limit this only to the Wi-Fi 6 access points, purely not because we're trying to make you buy them. It's a pretty good idea, but also just the pure grunt that we need to run. There's a lot more, grunt in the newer access points, basically being newer. So here's an example of what we would see currently on a Meraki network, where there's a lot of this miscellaneous secure web because it's encrypted, and we can kind of fingerprint it by where it's going, but it's not always easy to understand what the application payload is. And this is after with NBAR on that network, where you start to see, hey, here's real-time video protocol, secure real-time video protocol, Zoom meetings, WebEx meetings, what we're connected to in there. And if you have all Wi-Fi 6 access points in a network, then we get to use this for layer 7 rules as well. There's more than just visibility. So really, really cool functionality. Another capability that's been introduced, and this is about, the journey to minimize the need for Radius servers and having to have Radius servers at each site. If I want to be able to limp home if I have no uplink connectivity. So we've added a thing called Meraki local authentication. This is the first phase of it in there. So what basically this does, and these diagrams are straight out of our documentation, is it allows a wireless client to connect to an access point. Normally would go via a radius server and then off to a back-end server in there. And so these are boxes in racks or VMs in clouds that need to be watered and fed and managed. So what local auth does is basically takes that radius server function and runs it locally on the access point. So therefore we could just start to point the access point off to LDAP or OSCP servers for certificates here to do that authentication. But then we provide a local caching functionality as well. So that means if I am connected off to this LDAP server up in one of my SaaS clouds, and I lose connectivity, clients can still authenticate because they're cached here. Their certificates are honoured and their authentication times are honoured on there. So, think of the scenario, remote site in regional Queensland loses the network connectivity because someone's dug the fibre up to that town. The clients come to work, they can still log on, they can still print to the local print server and get to local resources inside there. That's what's also been added, and again, that's just included in the access points. So the one here that I will talk about that I talked about last week in relation to the switches, and it's adaptive policy or scalable group tags, SGTs, also called security group tags on the access point. So this does require an MR advanced license in there that gives us that next level up functionality. So remember, we have per tier licensing, not per feature. This is part of the advanced tier. If you don't need it, you don't buy the advanced tier, you don't get it. It's that simple. So this is all our, again, Wave 2, 802.11ac access points and Wi-Fi 6 access points get adaptive policy. So I won't go into detail on adaptive policy. I covered it last week and be shared out. If you're interested in tagging right to the edge of wireless and in there, reach out to the team and we can talk in more detail around that. Another functionality added is actually in MR26, but really you should be running MR27 in all your production networks now, is this thing called rolling firmware updates. So previously with the Meraki wireless network, if you wanted to do a firmware update, you would pick a time out of hours, or you'd move our schedule to be an out of hours update, or you'd have that time set where it happened at 3 o'clock in the morning or 10 o'clock at night, where all the access points would get updated. So we'd trickle out the update to the access points that all reboot and everyone would get kicked off the network and everyone join again. So not a great experience. It probably didn't matter at a remote site, after hours. But then we have, a lot of places inside large enterprises and that where they are 24/7, or even, some retail locations and the likes. Oh, I need to get this patch out straight away for this, wireless vulnerability or whatever. How do I get that out there? So now we have this, minimized client downtime capability. So what that does is in the back end, you don't get to control this. It auto groups the access points based on their utilization, client connections and what's going on inside there. So they will identify a group of access points and we'll upgrade those first. And then what we'll do is we'll artificially try and push clients around to those access points once they're back on the network. And then we'll upgrade the second lot of access points. We'll do all the best we can around trying to get those clients to move inside there to minimize that upgrade. So typically, I've got 2 access points in my house, for example, is if I do this upgrade in the middle of the day, I have no kids complaints, that works okay. I've also look after a couple of not-for-profit networks as part of my time to give that Cisco gives us, and I do their wireless upgrades during the day. I did one the other day for one of those while I was on site, and no one lost connectivity. There was no complaints. It all just keeps going. So it is, very scalable and easy to manage inside there, and we try and make that as easy as possible. The boxes, like I said, Meraki is all about the dashboard. It's all about the cloud. Then you have to have wireless access points on premise to do that. So the boxes today, and we launched a new one last week, which is this MR44 inside here. So this is the Wi-Fi 6 access points, which I'm going to cover. If you're buying wireless access points now, you might as well do Wi-Fi 6. The cost difference is not any worse or the same. A little bit worse on some of them, but most of them, it's pretty much, on par with what you'd expect. The bunch of access points here, these are indoor access points. We have the MR36, 2 spatial streams, 4 radios inside there, so 2.4 and 5 gig, 2 spatial streams, Wi-Fi 6, supports Wi-Fi 5, of course. in there. So that your retail shops, small locations, remote sites, buildings, low density, sites inside there. Then we've introduced this MR44, which has 4 radios still support the thing called MGig, which is supporting 2.4 or 5 gigabits per second over the same structured cabling as your 1 gigabit per second cabling, so that we can get all that radio beautifulness of throughput back into our networks. The difference with this, guys, it's got 4 stream 5 gigahertz and 2 stream 2.4 gigahertz. Because we see, less clients on 2.4 gigahertz because the frequencies available, the spectrum width, the channel width, and that kind of stuff just isn't as high. So these are really aimed around that education space to keep to have a lower cost version of, say, the MR46 in this case, and still have a great Wi-Fi 6 access point, for throughput. Then the MR46, which is a 4 spatial stream 2.4 and 5 gig radio, MGig as well in there. This is what would be our bread and butter access points for enterprise buildings of any size. Probably where I would start with an access point, and then go down or up based on the client site. There's 2 flavors of this guy, is MR46 and 46E. The 46E has, as you can see there, external antenna on it. So, so we expose through here, 4 client servicing antennas, and then there's a Bluetooth antenna and a scanning radio antenna on those guys. And then the flagship, top of the range, 8 spatial stream, 4 radio, MR56. We would go to this guy for high density, lots of client support, for per radio, those sort of areas in there. Outdoor access points, we've got 2 inside here, these MR76, which is the 2 spatial stream 4 radio, and MR86, 4 spatial stream 4 radio, with MGig support on those guys. Just more client density, really in there. And then these guys are shown here with the omnidirectional antennas. They can have directional patches or antennas on them as well. And then just a refresh, so this is still all the current Wi-Fi 5 access points in there, where, really the Wi-Fi 6 access points, we've focused on having an equivalent to the general purpose and high density access points here, where we've got 2 spatial stream 33, 3 spatial stream 42, and 4 spatial stream 50s. And then outdoor we have the 2 spatial stream 74 and 4 spatial stream 84. So, you'd look at Wi-Fi 6 inside there's where I'd go, unless you're trying to fit into an existing area where you've already got deployment of access points. It's sort of sensible to stick to the same ones, or try and rejig my network to not roam across different types, and that just more so from an RF planning point of view than the capable. We don't really care. Like a lot of locations will run 36s, in the foyer, and or 33s and 40s back of house, or 50s, and you can roam between them okay. It's just a planning sort of stuff because people make the job simpler than harder. What is still not replaced in the Wi-Fi 6 range are these hospitality access points, the MR30H. We will refresh that in the future, but there's sort of not a immediate need to have, Wi-Fi 6 in a hotel room for the 2 or 3 devices that connect to it at this stage. Is not, apart from future-proofing, it's sort of not really a focus area. We'll get there, and we'll do that guy down the track in there. And then the entry-level guys, the MR20, which is a 2 spatial stream, and MR70 2 spatial stream as well, indoor and outdoor access points. These guys don't have the Bluetooth transmit and receive radios, and do not have a full-time scanning radio on them. That's what I didn't cover with all our access points is all access points, apart from those 20s and 70s, have client servicing radios, and then they have a full-time scanning radio for listening to all the frequencies around there, so that we can make all those decisions inside there. What we have seen is, that was sort of a Meraki thing that they always had at access points. The whole industry pretty much has followed that lead. And then Bluetooth transmit and receive radios and all these guys as well. So we can listen to beacons from Bluetooth devices like these guys, or here's a Meraki sensor, which I'll talk about next week, where we can listen to the Bluetooth and those, and we can also be a beacon. Hey, I want to run an app. I want to know where I'm geolocated based on Bluetooth beacons. All our access points could be a Bluetooth beacon as well in there. So what else are the extras that we added to? But earlier on, I talked about, our spectrum analysis capabilities and visibility in dashboard and performance and what's going on there. So what we have added is a whole heap of capability around a thing called Meraki Health. Now, you would have, if you are a Meraki customer, it was called Wireless Health. Been just changed to be Meraki Health because it covers more than just wireless nowadays. We're starting to look at the whole portfolio in there. It's not something we charge extra for. It's included in the device inside there. It's designed to make it easy to identify problems, simple and easy to use, and just leverage all our smarts in our back end. Now, all our smarts in our back end, I keep calling it that because I tend not to try to use industry marketing words such as machine learning and artificial intelligence, which is really what we do. We collect a bunch of data in the back end. We run that through analysis engines, and then we give a meaningful outcome is what it's all about. Or we provide data to help triage a problem in there, and that's what the back end of that does. So this is a pictorial showing exactly what I talked about, which I should have had on the last slide, which sort of says, hey, how's my network running here? I've got Google Drive running, I've got, Office running, I've got Salesforce running. How are my applications running? How's my network running? My, distribution switch, my access point. How's the clients, looking inside? We'll have a look at this in dashboard in a minute. But that's what we're trying to, what we're trying. We are bubbling up in the dashboard. Trying to make it easy to understand, easy, quick root cause analysis. A thing called actionable insights, which is what we're adding more and more of that functionality as we go along, where rather than say, hey, the client disconnected because of low signal strength, it says, hey, the client disconnected because of this. And this is what you need to do to fix that, or, hey, that's a client problem, to try and make it really simple inside there. Having the right data at the right time. Before with Wireless Health, you had to go to the Wireless Health tab to see all our Wireless Health. Now with Meraki Health, it's sprinkled throughout the dashboard to make it easy. Oh, I'm looking at a client, here's their problem in there. And then that full stack, bringing in the intelligence every single hop in our stack from a Meraki full stack, visibility in there. And last week, I think I answered a question around DNA centers, is then also pushing a lot of this data into there. So if you're running a hybrid environment and you've got DNA center, is pushing a lot of the assurance data over into there. So you've got that single view, a single dashboard view from a Cisco point of view. The wireless issues really fall into two categories. I can't connect to, the complaints we get is I can't connect to the wireless, in which case we pretty much know it's going to be like an association roaming issue. They can't authenticate because their password's wrong or the certificate's expired. The DHCP server's depleted or, taking too long to give IP addressing, or the DNS servers, again, aren't responding or taking too long, So everything might be working, but I can't resolve an IP address to a host name. I can't remember the IP address for Office 365. That can, look like I can't connect to the wireless. Or the wireless is running very slow. Now, that's going to come back to, so the top ones are kind of easy to triage, it's sort of off and on. The bottom category here is, receive signal strength, signal noise ratio, what data rate the clients, connected. Are they connecting to their local access point or an access point, 20, 50 meters away, 100 meters away, which is causing issues? What's my channel utilization? How many clients on the access point? What's it going on? And this is my pure wireless latency, that round time trip over the air because of how far I am, or, hey, all my traffic's been marked as lowest, priority, so therefore I'm getting the worst service, looking inside there. So it's about trying to make all of this, and there's probably a few others, much easier for someone to see. This is the way it looks in dashboard. We'll actually go and have a real look at this, so I won't dwell on these, but nice, easy to read graphs, but then the actionable insights inside our client timeline, like why are they connected, what's going on inside there. I'll quickly cover this and we'll have a look at the dashboard. So inside MR27, we've also included a lot of enhancements about location services inside there, and a thing called MQTT for telemetry. So a lot around that IoT use cases and having sensors on networks and sending that data through in there. So what location enhancements version 3 does for us is really us stream out our API. It also is a lot of work in our back end to make it smarter as well. Before, we just used to send a bunch of data at random intervals about every single client based on what the client is doing at that time, which could be quite noisy and pretty hard for some people to grab that data and do something with. So what we're doing in Location Services 3 is make that a single post per network to make it easier for application developers to grab that data and do something with it. because we also then, use our synchronization of all our access points and this location data and grabbing all that data and doing a bit of compute ourselves inside there, that helps with the accuracy of location. Like if I'm getting, 2 beacons from 2 access points and it's 100 milliseconds apart, but it's really the same beacon, that puts my accuracy of location for a client out by a lot of meters. So we can synchronize those, and that'll bring that back down, to be that, 2-3 sort of meter area, depending on your wireless location install. If I've got one access point in a building, it's not going to be that great. If I've got a building with an access point in each corner, then my triangulation or quadrilarization is going to be much better in that. Now, the telemetry transport, which I said is more around that IoT use case. I should have not put MQTT here. You'd hear it's called Mosquito in the industry as well. But it's really just like a real-time feed of data from a client. So this device here, this is a Meraki door sensor. If I pop the sensor off, it sends an alarm, sends it back on. Now, that alarm is sent via MQTT over there. It's real-time telemetry. If I had a temperature sensor there, it just sends that data inside there. What we can do for non-Meraki sensors like this sensor here, which is a non-Meraki sensor, is we used to just say, hey, I know where this Bluetooth device is on my network. It's sending out data. What's its battery life? What's the temperature? And that kind of information. And we used to just bin bucket that information. So what we do now is we will send the data, the payload of that Bluetooth device's data straight out via MQTT to the application service providers, to whoever. And in this case, this one's a Milwaukee tag, so it can get sent straight to their server and know a lot more information about what's going on in there. There's a lot of stuff happening here around things like electronic shelf labels and a few other partners in our ecosystem around door sensors and temperature and push buttons and all that capability. That's using the Bluetooth capability on that with the MQTT feed off to their servers. So I'll have a look at dashboard here just to sort of show some of that functionality. I'll just log back on because I talk too long, so therefore it logs me off in there. So this is Meraki Sydney office, bunch of devices on that network. What's our health going on? I can click on, wireless health. This is what I said of the old way of going and finding out data, and here I can see how that network's going. Now, straight away, one thing, if you're familiar with the Meraki dashboard, this is really just going to the access point tab, and then we've added a health tab in there to help look at that way. But if I'm really triaging a client, I'm not going to go, and look at the whole network. I'm really going to go to that client. Someone, contacts us and says what's going on. So here I can go and put the user down here. So I got, authentication inside there. So now I might go, let's go and find a person. So, here's Stephen's MacBook, for example. He's contacted support desk and said, hey, my wireless isn't going that well. Can you have a look at it for me? Or no, probably wouldn't be that nice. It'd be like, oh, it's all rubbish. Fix it. So straight away we can see from the dashboard here, look at all the information about this device and its capabilities, so I can see what's going on inside there. I did talk about before that I can just go and filter. I didn't talk about that. I talked about packet captures. Here I could just jump straight. I was doing a different tab. Jump straight to a packet capture where I can just automatically filter and packet capture for that access point for that client if I want to go and do an air capture or a LAN capture of that device to help, triage some sort of issue. I have event log here, which is then context filtered to that device as well, so I can go and see those logs inside dashboard, all the various logs of what that person's done. Here you can see I'll also get the approximate geolocation for that client or where they're on the network, so I can understand what they're doing. And then a nice little view here of how they're run through the network, each client device. So here's the access one I'm connected to. I'm connected to an SSID called Blizzard. I'm happy on that network. Inside there, what my channel utilization is and what switch I'm connected to, and if there's any problems on that. So nice and easy to see. And further down here, I start to see this wireless health information. It's apart from our normal client view and our applications that person's using. These are obscured because I'm in read-only mode, which doesn't allow for that. But here you can see straight away that maybe we have got some issues on this network. Network latency looks good. So I can just click on this graph, which just really just cross-launches across the top here to the next tab and go and see what issues and errors there are on that client. Here I'm getting 25% client auth, so I can just go and click on that and go and look straight at the connection log for that access point, for that time, filter that to see what's going on in a log sort of format. The performance data is all contained here as well. So now I can start to see what applications are his top applications he's using. This blue line in the bottom here is when the device is associated to the network. Then I can start to see the throughput and any roaming or occurrences happening across that environment. What my signal to noise quality is for that client. Obviously, he's turned off his laptop there and he comes to work at 9:30. That'd be about right. But you can see, signal strength and whatever's going on there to help work out what's going on. And if I roam across access points, you'll see that change as it goes across access points and how many clients are on those access points. And like here, my average wireless latency, obviously he's not going that slow. It looks cool. And then from an AP point of view, channel utilization, the likes in the number of clients connected to it, which can be important when triaging a problem, and the data rate that this client's achieving across that from an access point of view. So nice and easy. But the main thing is this history tab here, which is that insights of what's going on inside there. So here's, the client unexpectedly disconnected with a client reason of 34. Now, clients have all different reasons to disconnect. So this case here, you'd go and search why, a MacBook has disappeared. We will, with the actionable insight stuff I was talking about, that's where we're going to bubble up more of that information to try and, give more of an actionable insight into the dashboard here. Well, here's a slow connection to him. The reason why it was slow is because the DHCP server was slow, but his signal to noise ratio was 20 dB at that time. So again, I still have to use a little bit of, my brain to go, well, that's a low signal to noise ratio because it's orange. But DHCP is slow. I'm seeing that a lot, what's going on in there. So trying to see through all that. The other cool bits on that is, then obviously, like I said, from the access point, I can go and look back out at wireless health as well. Say everyone's reporting from one corner of the office. I'm having really bad wireless issues. Before, we would have gone to the RF tab, which is that stuff I showed you before that shows clients connected and any alerts or alarms on that. Let's see if there's any alerts. No. That are on that, so I can help you triage. Here's one here where I can go and say, hey, what's going on inside their device rebooted from firmware update. But now we've added the performance tab on the access point as well for that same triaging capability where I can go and see now from an access point, looking out point of view of how my wireless network is running. And we've also bubbled that up to the front page here where I can go into the uplink traffic of that access point, what clients are currently connected to it, and what they're doing inside there, how everything's functioning, DHCP, DNS, and that from there, and the wireless health now from that access point, looking out point of view, in there to make it super easy to do that in there. So the only other bit I was going to quickly show was that identity PSK capability. So let's hope it's in here. So this is identifying if I want to go and configure identity PSK, I'd go and create an SSID, I'd rename it. And then I can say, hey, let's go and create, this is an identity PSK SSID without Radius server. And then I can just go and add this inside here. So here I just go and add, a name for this client devices. I might call this light switches or something. Always use underscores. And then I give it a passphrase of, light switch pass hash to make it complex at the end in there. Then I can give it a group policy, which I can go and define. So group policy might be light switch group policy. And in that group policy, I would then go and have different functionality. And that's as easy as it is. And I can go and create multiples of those on my network, to authenticate these random devices. Or, I might even want to use this on a contractor's network where I can just give everyone a pre-shared key because I don't want to use a splash page because management says that's too hard or something. Then this one option here, and that way I can group users. That way, if I wanted to kill the light switch group, remove it from the network, I can just click on that and delete that off there, and then all of a sudden, none of those clients can connect to that network. Now, the group policy I didn't cover, but if I want to go and create a group policy on there, I can just go and create one which will be bound to those devices. Group policy, if you haven't seen that, looks like this, where I can then go and say, hey, schedule at a certain time. This is going to have a custom bandwidth limit for these devices of 250 kilobits per second. and I'm going to go and do some custom firewall rules on here. I'm going to deny them access to anything on my local network. Really simply, so that means they can get to the internet or whatever, or my proxy server in some cases, but they can't get to my local network. And they're obviously going to apply umbrella policies on there if it's in there. A layer 7 firewall rule where I can say, hey, it can't get to certain countries, for example, inside there. So that's as simple as doing a group policy and how that's bound. That's then bound per user or per client device and nicely simply managed in there. That's pretty much what I was going to cover today. We've got 5 minutes left for any questions on that.
So there are 3 questions that have been raised, Scott. I'll just run through them. First one is, we hear a lot about AI and ML, artificial intelligence and machine learning. What's Meraki doing in regards to these? Yeah, so
the basis of Meraki from inception is really around using the power of the data that's collected inside there. So it's always sort of been a capability to, like auto RF and those sort of functionality is really, running a self-tuning algorithm across those. So, you could call those, that sort of functionality. When you start looking at Meraki Health, you really start to see the power of, what we're doing around machine learning. Hey, the network's behaving like this. So therefore, we should be changing this. And that's where we're going to start to see that actionable insights pop into Meraki Health. We start to see, just you need to go and do this to solve that problem, or all the clients are stuck to this access point. Click here to, change your RF profile to suit that. And that's where we'll start to get the power of, the machine learning capabilities. And then, that brings in artificial intelligence where we start to have those insights and actionable. Self-tuning is definitely part of that network, but we also don't want to self-tune off the planet where you stop clients from connecting as well. So it'll start off with clients interacting with that a bit, and then move to more and more artificially doing that for them based on the feedback and what we collect throughout the world on those functionality inside there.
Yep. The next question is, we're looking at 5G. Do we still need Wi-Fi if we've got 5G?
No, you don't. No. Only kidding. So 5G there's a couple of, things with 5G. There is the long range stuff, which will eventually replace 4G or LTE, which really has some enhancements around channel bonding and that kind of stuff for high speeds. But it still comes back to the bandwidth for the cell, or bandwidth for the edge of the network, and the number of clients connected. Whereas Wi-Fi can help aggregate a lot more clients into a smaller area and then use something like 5G as backhaul. There's also millimeter wave 5G, which uses extremely high frequencies, which won't penetrate buildings and won't get into, those sort of areas inside there as well in there, or the design for inside there. And that's going to be the super high speed gigabit plus functionality. So if you want gigabit plus inside a building, designed and managed and guaranteed sort of availability, that's going to be where Wi-Fi 6 fits in. If you want roaming on a client, going all across field sides, and 100% 5G, 4G or 5G will cover that. High speed, close to a cell tower, millimeter wave 5G will fit there. So it's really a balance of both of them, meeting the business needs of client roaming and throughput, and guaranteed throughput and availability in there.
And the final question is, we've got we use Cat5e cable in our buildings.
Yep.
What do we need to do? Do we need to upgrade that and our switches if we want Wi-Fi 6?
No. It depends on so there's a lot of work done around a thing called MGig or multi-gig, which is around using Cat5e or newer, even Cat5 to a point, to try and get higher than 1 gigabit. Because which I didn't cover in this session, what Wi-Fi 6 gives us is a lot more throughput if needed in there. So the access points, 3.5, 3.6 gigabits per second, for like an MR40 odd, in there, really 2.5 in the air. In the wire that's in the air after you remove overhead and that kind of stuff. So therefore, MGig allows us to get that back to the switch, because it allows us to do 2.5 or 5 gig or 10 gigabits per second over existing cable, Cat5e or Cat5 cable, but has distance limitations. So yes, initially we'll be using mgig, and it'll always derate back into 1 gig too. There's also power usage. As we see all these new access points, a lot of them are PoE plus, lower end ones aren't, all the rest of them are, where we're starting to go above that 15 watts as well, where we need like 17 watts, 18 watts, that kind of stuff. So they're in there, but that'll still run over Cat5e. It's just condition of the cabling plant, the distance it's running, to get that throughputs there. And you just got to think logically about this as well, because it's not all about, getting 2.5 gigabits per second per access point. If I've got a 100 meg link out of my site and I don't have any local servers, it does help to design that correctly, but, just think about the benefits inside that as well.
No, that's great. Thanks very much, Scott. Well, we're just coming up to the hour. I'd like to thank everyone for joining us today. And just to remind you that next Wednesday we'll be running part 3 of the 4-part series, where we'll be covering beyond surveillance, smart cameras, and the new approach to analytics. Thank you very much, everyone, and have a great afternoon.
Thank you.